Got some serious go time happening right now. That's right, railroad glasses back on. Let's press some track. That's right, we've got the first section laid out right here, and hand pump is hooked up to the 50-ton cylinder, and everything's in place. We're well greased. Let's make it happen. I like to start this bushing driver just in there. That way I know everything's gonna line in properly. Top brace, click it down in place, ready to push. Just want to show you on the hand pump, I've got the gauge so it not only shows the pressure in pounds per square inch around the outside. This is a 0 to 10,000 psi pump, but we have this outer ring is 50-ton ram. That's what we're running right now. So we have the tonnage ratings according to pressure as well. So I'm going to be back here. Behind this steel table is my station. So I kind of have between the back brace, just above the links right there, and then this top brace that goes between the two backstops. That's a pretty good scatter shield between all of that deflecting pieces, V'ing them out away from me, plus anything else is going to have to come through this table before it gets to me. So we are dealing with some tonnage here, make no mistake. And I'm going to set you all up in here. You're on the tripod right now, but we're kind of folded up. I'm going to get you a good spot to sit, and hopefully everything cradle you in here really well, so bear with me. Hopefully everything behaves itself and camera stays right where I've got you right now. So we're going to start pressing. The bushing driver is going to disengage the bushing from the tail end of link down here. The pin driver is going to disengage the pin from the link. So we're trying to free this link half right here. Backstop in place, bracing the top of the cradle. Everything looks like it's lined up. I'll call out the tonnage. Let's push. $10 tons, 12, 14, 16, 18, bumped up to 22, 26, 28, 30, 34. We're at 36 tons right now. There's 40. That's about 42. 44. We've got it moving. It jumped back to about 35 tons right there. We're back up 36. Popped at 38 tons again. 38 tons. That was about 36. We're running about 30 tons right now. About 30 tons still. We're about 25 right now. We've got it on the run. We're consistent 20 tons right now. We're about 15. I think we've disengaged the bushing. We're just pushing on the pin at this point. And there, I saw the chain jump, so I believe the pin has released. Cylinder's going back. I have to pull the table back manually because we're not positively attached to the cylinder. But all right, we're just about fully returned. Get you all off tripod. We'll have a look at what happened. Let's get the top brace off. Alright, let's free this camera up real quick. There we go. So this is what we were trying to accomplish. You can see we've disengaged that link half right there. We can now withdraw. Boy, there's a lot of rust in there. It's been a while since these have been used. We can draw the other link half that still has the bushing and the pin in it. This link half comes off of our drivers, and bores look good. Bushing and pin looks good. So set those together, and I've been lining them up over here. Just bear with me. Here's what we've done so far. So all in all, not exactly disappointed with its performance. We just leapfrogged the chain ahead once again. Just start that bushing driver so we know it's going to line in properly. Top brace back in place. One thing I like about actually using that lower part of that H-beam is I have like this spine that runs along the center, and absolutely is going to prevent it from buckling at all. It looks ugly, but honestly it's really useful. Alright, I'm set up to press the next link. I'll just let y'all watch the gauge right here. We can see what kind of pressure we get. So again, we're on this outer ring scale. That's for the 50 ton. Feels like we should be approaching 20. See how close I am. Looks like we're about 25. Getting ready to let go. Where are we? Boy, we're about 38 tons right now. We're really pushing on it, this one. There, the bushing finally let go. The pins move easy, it's the bushings that are tight. Every big bang is that bushing finally moving. Small ting was the pin. Small ting was the pin again. Boom, that was the bushing. Usually the tonnage goes down the further out you get them pressed. Pushing pretty easy now. There, the bushing is out. We're just drifting the pin the rest of the way. I don't even know what we're reading on the needle. Yeah, we're barely registering. There, I saw the chain jump. We're free. Camera is about to fall over. All right. And of course I stop quite often and give everything some fresh grease. One improvement I think I need to make is something to protect this area right here from all that rust, dust, and everything, that powder, from getting down onto that greased table, because the grease just collects that stuff. Thinking about anything I could put on there to just shield it a little bit, even if it's just a rag, I might just start throwing something down there, because about every 3 passes I have to go and clean all that out, and then I put some fresh grease on, and of course it keeps me greasing this regularly anyhow. So getting all these guides on each side, hit the back of the table as well. We're pretty full of grease beneath it, because we're starting to see it actually come up between the table halves, so happy about that. All right, I have found a stubborn link. I've maxed the pressure out to the full 50 tons twice, and it hasn't moved. The good news is we have given the press frame the ultimate test. Everything held up, nothing even moved. So I'm gonna try some heat on the bosses of that link, see if we can't get something moving. Get you guys just far enough out of the way that I can work here. And we don't have any pressure on this right now, I should point out. See, we can, there's no way I'd be sitting here with pressure on it heating at the same time. That's we're dealing with a lot of force here, and you want to keep safety in mind. This is a dangerous job no matter how you approach it, just because you're putting that much pressure on things. I mean, I've worked with press fits for the better part of 20 years in the auto industry. We rarely ever got up to anything this high, but I've had pieces blow up in a hydraulic press on me before, and we're talking probably at 20 tons, maybe even 10 to 15. And trust me, these things turn into bullets. The piece that blows up will have either hit you or have passed you before your brain processes what that bang noise was that you just heard. It's literally that fast. So it's not for the faint of heart. All right, we've got a little bit of heat on things. I'm going to get the torches back out of the way again in case of that shrapnel factor. That was 48 tons. Got it moving now though. Okay everybody, it's time for the after action report. You can see here I've got both of those track chains broken down. Now once again, these were the extended length D2 chains that I got from that Vaughn Combine track kit. So a standard D2 only has 30 links per chain. Because that Combine kit was a much larger footprint, these were 45 links per chain. So we pressed apart 90 total. Well, with the exception of, let's see over here. One side they had already went and torched one of the links in half, so we got a freebie on that one. I just slit that with the torch on each of the bushing bores and just let the bushing fall right out. But with the exception of that, we've basically got, well, just shy of 90 chains here, or 90 links, sorry. And once again, yeah, these were the ones that originally held the 20-inch wide Super Swamper track pads that are going on 5J1113. Now, for the whole reason why we're doing a pin and bushing turn on these, let me come over here. I got my gauge handy, and track press did great, by the way, close to 90 cycles on it, still ticking along just fine. So because these were on that Combine, there's not a lot of link wear at all. We'll just set the gauge up alongside of this one, and you can see they are fat yet. So for roller wear surface, they're excellent, but you can see we do have a step right there. They've got some pin and bushing wear going on, and that is partly because of those super wide track pads that puts a lot more twisting action on the tracks. So you do get more internal pin and bushing wear. So with a pin and bushing turn, that should bunch all the slack that is accumulated in these links, and we can get one really stand-up set built for 5J1113 that's also going to hold those 20-inch wide pads just fine. And I've had a couple people in the comment section say, well, it doesn't look like, let's just get that off of there, and they say it doesn't look like there's an awful lot of wear on those pins. Well, when I measured the actual stretch on these across 5 links, or 5 pins, 4 links total under tension, we were right around 65-70% of the way to 100% worn spec. So they were ready for a turn. And you got to remember, it's not just the wear, the step you can see just on the pin. There's also resulting wear inside of the bushing too, so you can at least double what you can see in one place right there. And it's a cumulative effect type of thing. You throw even that much wear across every pin and bushing joint, it adds up to quite a bit by the time you get out to the idler adjustment point, and you also start running your bushings out of pitch with the sprocket teeth so that it results in more wear all over. It's just better to get the turn done on these, bunch that slack, and we'll have one really nice set of track chains for 1113. You might have noticed in this other lineup we're missing a link. That is because I discarded this one right away because I noticed it had an old crack in it. That's rusty enough. That did not happen from me pressing. That had been there for a while, but this link has already failed, so I tossed it out right away so that I, didn't have a chance to overlook it again when we do the second stage, pressing out the remaining pin and bushing from the other link half. You will remember also some of these 20-inch wide pads had been running loose in the past, and I discarded some of those for that reason. We will also be scrutinizing every one of these links to make sure the holes are good, that the mounting surface is nice and flat yet. Any of these links that had a loose pad on them are not going to be put back together for 5J1113's tracks, but because we have 15 surplus links roughly in each one of these sets, we have plenty that we can potentially discard and still have one really good set of chains for each side. And to the track press, no complaints whatsoever. We're kind of fighting some morning glare here. Take a look over here. I had to redress, and this one is starting to mushroom out once again. I had to redress both of the drivers once, about 2/3 of the way through, because you do get some deformation on these, and the pin driver would swell, and you can see when it swells it starts to score a little bit as it pushes through the link bore. This is softer than the link, so it didn't scar the links at all. But yeah, I expected for there to be, you know, some wear in this area here. These are my weaker points, but all in all, I really can't complain with how it performed whatsoever. You can see we get plenty dirty, and I mean, it's so rusty. I threw this down to protect that beam from, you know, getting all that rust stuck in the grease down there. We're just going to get rid of that straight away. But yeah, there was actually a lot of comments under the assembly video for this where people already want to see a fresh coat of paint on it, yellow paint, what have you. You can see right here from setting the links up, it gets, oh, these things get so dirty and just so beat up that I was not going to spend any time at all putting paint on this. In my mind, it's not necessary, A. B, like I said, you're just going to be knocking most of it off and getting it full of scratches and rust and dirt anyway. C, you have to remember we're not done building this thing yet, because this was only like phase 1 of disassembling a track chain setup, and I am going to be retooling it and reconfiguring for the reassembly process. It's going to require different push points, different dies. So we're still going to be drilling holes and welding on this, and new paint in the way of all that would just be a hindrance anyhow. So very likely it's not going to see paint at all. One of these days I'll train you guys to see paint for what it really is. We're getting there little by little, but yeah. And two, a lot of the heavy blocks and steel I used in this are still good for other press adapters and pressing jobs. I don't want to have a thick coat of paint on things that I'm going to be taking out and potentially setting under objects and putting in a press anyhow. So I prefer to leave all that stuff in the raw. Now, as long as I've got some links here that have been pressed apart, it's a good time to answer a question I've seen several times in the comments. And people ask exactly how and where do these wear upon each other. Okay, we covered the link height issue. In other words, the area, the surface that the track roller rolls on, that is hardened on the surface only down to a certain depth, and once that hardened surface wears away, you get into the softer metal of the link, and then it's no good because it wears out way too fast. That is one area where they wear. The other area that we just briefly touched upon is internal pin to bushing wear, and they wear primarily on the tension side. So you have track tension trying to pull these links apart from one another. So you're going to get the most amount of wear on this front edge of the pin and the trailing edge of the bushing. And like I said before, you couple both of those wear aspects together, you can see the amount of clearance that is built between that pin and that bushing. So that's where all that comes from. These are meant to be a dry running track, and again, these pieces are super hardened to be wear resistant, but they only last so long. I have this example of a new pin and new bushing, and you can see very little clearance inside that bushing. The pin really doesn't float around at all. That's what they started out as. So by pressing the pin and the bushing the rest of the way out of these links, turning them both 180 degrees, you are rolling the unworn portion of the pin and the bushing around to be in mesh or in contact with one another once again. That's going to put the excessive clearance to the back, opposite of the direction the tension is being pulled, and it bunches the chain back tighter again. The last thing I wanted to show y'all, as long as we had all this stuff laid out right here, is the difference in the master pin and bushing as opposed to all the rest of them in the track. So as you remember from 5J1113, that still had the older style taper plug setup master pin in it, where you remove those taper plugs and it actually collapses the pin a bit so you can easily drive it out. The later ones are a pin that look just like the rest of them, solid, but it's just slightly undersized so that it drives out easier, and it's usually identified by a dimple or some other sort of mark in the pin itself that sets it apart from the others. The bushing, however, on the master link is shorter than the rest of them. So you can see this one right here. You can see where the press, this is a standard bushing, you can see where the press surface is, but it sticks out a bit beyond the face of the link. You see that? And what that does, it actually rides in this counter bore that's just outside of the track pin. You see that step back in there? That provides additional alignment support for the link to the bushing, to the other link. But you look at the master bushing right here, you can see it's flush with the outside of the track link. And that is so after you remove the master pin, you will find there's going to be a little washer, a little spacer that goes into that counter bore in the link and just fills that void. So to demonstrate why that master bushing needs to be flush with the face of the link, because after you remove the master pin, it allows you just to slide the links right off of each other like that, and you don't have that step bore inside that's going to be hanging on an exposed portion of bushing like that. If you had a standard bushing with a master link, you'd still have a lot of trouble getting those tracks broken apart because you'd be hanging up on the inside. One other difference to note, the earlier first generation D2 track links, which I have a pair of them right here, and you can see they are both new. These are pure unobtainium right here. They've never been used. But the early first gen master links, master pins I should say, had these reliefs cut on the shoulders right there because they had a cross pin that went through the master pin to retain it, and therefore they had no counter bores on the back side, and they had no need for these filler washers to fill that space. The reason why they went away from this design, well, A, those cross pins would like to break and fall out and allow the master pin to drift out anyhow, so it was an unreliable design. B, this meant that every track had to have two special links in them that did not have that counter bore at the backside, and that was just more parts in their inventory. Going to this little spacer setup and everything else, that just simplified the whole process so that every track link is now the same. The only difference is the bushing, the spacers, and the special master pin where it needs to be on the link that you break the track. So hopefully that answers some of those questions. Now, the last thing I wanted to cover before I let you all go, people in the comment section under the last video as well said they've seen track presses before, but they've usually only pressed one pin or one bushing at a time, not a pin and a bushing in the same stroke to disengage an entire link half. There's a give and a take to both setups. So this is technically the most efficient way to press track apart because although it takes more force, you're only having to initiate a press stroke of about an inch distance total. Whereas if I was going to push this pin all the way out, that's a 6-inch stroke under pressure. The bushing is probably still a 4-inch stroke under pressure the whole way. Granted, this is only half disassembled. We have one link half free. We still need to press out the bushing and the pin from the other ones. It is possible that I could use my same track press setup and just set these in individually, press the bushing and the pin out in one remaining stroke. I don't think I'm going to do it that way. I think I'm going to set up to press each one at a time to finish the disassembly process because I want to retain the integrity of that machine for disengaging a link half initially to get it apart, and then I'll do the pin and the bushing turn one at a time, get it back to this stage, and then press that other link half back on in one motion with that machine to reassemble the track. I don't know how long that is going to last. You don't know how many cycles are in a home-built machine, so that's the way I'm going to do it. Plus, I think it'll be fun next time setting up to see how much force is required just to move one pin or one bushing in a D2 track link. Overall, I would estimate it took around 40 tons of force to initiate movement on the majority of these links. So it's not an easy job by any means, and I'm glad I went with that 50-ton capacity cylinder. My initial thoughts were to build the press around the 30-ton cylinder that I already had, see how it was going to work. I'm glad I just decided to listen to the voice in my head saying you might as well tool up for a 50-ton, you're going to need it anyway, because I've more than proven that my 30 would not have moved the majority of these links. So even at that, pushing 40 tons on that cylinder, we're still talking 7,500, 8,000 PSI in the circuit. This is no joke. You need to have, like the hose coming off my hand pump is in very good condition. It's almost brand new. Brand new cylinder. Just that 50-ton OTC hollow ram ran me about $1,500-ish plus dollars. But you need to have quality equipment that's going to hold up to a lot of cycles, and it needs to be in rather good condition so that you retain as much of that safety factor as possible. I can already tell you I'm not interested in doing any tracks bigger than D2, and these are just small little tracks. In my opinion, home-built equipment can handle this the way I have it configured. Personally, I have no interest in pushing the limits any further than what I'm already doing because it's already dangerous. There's a lot of opportunity for parts to explode, hoses to split, cylinders to crack. Any one of those things could really seriously cause injury, maybe even death if you're not careful. So this is not a job that I plan on doing a lot. I'm going to do it just enough to suit my needs, and after that I'm just going to use all those brand new Italian aftermarket track chains on everything else, because this is kind of just to do it and to, you know, demonstrate it more than anything. We can keep OEM good cat factory pieces on 1113, but all my working cats, I don't mind if they have non-cat rails and links and everything else. So that being said, I'm going to start tooling up to get the pins and bushings pressed out of those other link halves. We'll get into that and examine the tonnages required and the process for that. We'll get them turned and then build all the necessary adapters to put them back together on the track press machine. So thanks for watching, everybody. This was kind of a fun time, even though it's heavy, dirty, dangerous work. So remember, safety first. Keep that in the forefront always. Hope to see you all back again.